Hello everyone. Today we are here for the next part of ratios chapter. Today we'll be dealing with different type of questions. Whatever we covered last time was different, and today we'll be covering another level, another type of ratios chapter. Now, the first thing is how to combine two ratios, two or more ratios in fact. To combine two ratios, you have to see which part is common in both the ratios, which variable is there in both the ratios. Suppose if for this particular question I have A is to B equal to 3 is to 4, B is to C equal to 4 is to 5. I can see that B is there in both the ratios. Now check what is the value of B in both the ratios. B here is 4 and B here is also 4. That means the value of B, the common variable, is same in both the ratios. So we can simply combine. Now there's no problem. 3 is to 4 is to 5 will be the combined ratio of ABC. I could do it quickly because the common variable was with the same value in both the ratios. So there was no calculation required, no working required. We can simply merge two ratios. And for the next one, if we talk about, we have A is to B 1 is to 3 and B is to C 2 is to 3. B here is 3 and here B is 2. It's not same. The common variable is still B, but it's not the same value in both the ratios. So what we need to do? We'll make the value same. B is 3 in one ratio and B is 2 in other ratio. So what's the common multiple of B? Common multiple of 3 and 2? I believe 6. 6 is the smallest possible common multiple of 3 and 2. So I need to make B 6 in both the ratios. So to make that, I need to multiply the first ratio by 2 and the second ratio by 3. I'm making B's value 6 in both the ratios. Same. And please remember that whenever you want to multiply the ratio by anything, the whole ratio will be multiplied, not only the B. So when I multiply the first ratio by 2, I'll get 2 is to 6 and the second ratio B is to C. If I multiply by 3, I'll get 6 ratio 9. So what we'll get? Now B is same, B is 6 here and B is 6 here. So my A ratio B ratio C will come out to be 2 ratio 6 ratio 9. That's the answer. Okay, this was about combining ratios. Now let me show you another type of problem which we can expect. If we are given some ratio A is to B's ratio as 2 is to 3 and we are asked to calculate some value A plus 2B over 3A minus B. I think we have learned lengthy ways of solving these questions in school. We divide denominator numerator by B, and we get some fraction like this: A over B plus 2, 3A over B minus 1, like that. Now we substitute the value of A over B and then solve it. I'll tell you the better way of solving this. Do one thing, simply put A equal to 2 and B equal to 3 and solve. This works. Simply we are putting A equal to 2 and B equal to 3. So what will it be? 2 plus 2 times 3, that's 6, and 3 times 2, that's 6 minus 3. Whatever answer we are getting, 8 over 3. Okay, simply put, substitute the value of A and the value of B and you'll get the answer. Now the next one is similarly, if A over B is equal to 3 over 5, then we're looking for the value of AB plus 2B square, 3A square minus B square. Now here also we can put A equal to 3 and B equal to 5 and get the answer. Please note that this substituting the values and finding the answer is possible only when the degree of variable is same with each part. Here it was single A, single B. So the variable's degree is 1 here, 1 here. It's 1A here and 1B here. In the next question also I can put A3 and B5 because the degree of the variables in each part is same. One variable, another variable. So degree becomes 2 for this part AB. Degree is already 2 for this second part because of B square. It's degree 2 because of A square and it's degree 2 because of B square. Since the degree is same for the whole expression, for each part of the expression, that's why we can substitute A3 and B5 and get the answer. We can solve it. 3 times 5 plus 2 times 5 square divided by 3 times 3 square minus 25, 5 square. So 15 plus 25 times 2, all right. 9 times 3, 27 minus 25, that's easy. See, 15 plus 50, and the new denominator is 2, so it's coming out to be 65 over 2. You can leave it here or you can leave it in decimal, that's okay. But please remember, we can solve using this method only when we have the degree of the variable, same with each part. Okay, let me show you another problem where we have cubes. We have three parts, a is to b is to 3 as 1 is to 2 is to 4. And we have all the three variables involved in the expression I need to calculate. Let's see if I can actually substitute a equal to 1, b equal to 2 and c equal to 4. But before that, I need to check if the degree is same everywhere. If I look at the first part, it's a, b, c. That means the degree is 3. There are three variables involved. Here the degree is 1 and b's degree is 2. So ultimately it's 3. It's 3 here. A square and c, it's again 3. B c square, b's degree is 1 and c's degree is 2. Ultimately variables are 3. So it's same all throughout the question. That's why I can substitute A1, B2 and C4 and get the answer. Now checking the next one, I'm given that A is to B is 3 is to 5 and I'm looking for this question's answer. I think I can't really substitute A3 and B5 here or get the answer because see, the degree here is 2. It's 2 for this, but it's 0 for this. 2 is all alone. There is no variable involved. It's fine for this one. It's fine for this one. It's 2, 2 everywhere except for this particular term. So the answer for this question is, it's not that we have some other way of solving the same question. No. We can simply answer this question as cannot be determined. Okay, there's no answer for this question. You can't actually calculate it. So please note that you can simply put the values of the ratio in the expression given only if it has the same power with all the expressions in the question. Otherwise, the answer will be cannot be determined. No second thought. Yes, we can solve it if they don't give us the ratio, but they give us the proper value. Suppose they are giving the value. Suppose they are saying that A is 4 and B is 5. Suppose anything. They are saying A is 3 and B is 5, whatever. If they are giving the value, not the ratio, then we can find out. Then we can simply substitute those values. But if the ratio is given, we have to be careful about the power distribution. Okay, moving ahead. This type of question, this question is about, there are three ratios, A is to B, B is to C, C is to D. They are not actually, in the previous question, it was just one ratio and we were given a ratio and we were asked to calculate the expression. It's this question, these variables are fine, A plus 2B, the degree is same everywhere. But here we are not given the ratio of A is to B is to C. We don't have a combined ratio. D is not required though because D is not asked in the question. We have different ways of solving this type of problem. First method is you combine the ratio. You combine the two ratios. A is to B is 1 is to 2 and you have B is to C as 1 is to 2. The common variable is B. So B is representing 2 here and B is representing 1 here. So to combine the two ratios, I need to multiply the second one by 2. So this remains 1 is to 2 and the second one becomes 2 is to 4. Now B is same in both the ratios. So we can simply combine. It will become A is to B is to C equal to 1 ratio 2 ratio 4. Now you can substitute this. You can just substitute A equal to 1 and B equal to 2 and C equal to 4. D is not required because D is not there in the expression. Otherwise we can combine C's to D as well. Another way of dealing with the same problem is when you have all the ratios equal to the same expression. I have A ratio B equal to B ratio C equal to C ratio D equal to 1 ratio 2. We can assume values. We can assume A as 1. If A is 1, B has to be 2 because of the ratio being 1 is to 2. And also since B is to C is 1 is to 2 and if B is 2, C has to be 4. So that B is to C ratio comes out to be 1 is to 2. And similarly, D must be 8 because you need C ratio D as 1 is to 2. You can take these values and substitute in the expression. I would have answered this question as well as cannot be determined in case the power of the variable is not same everywhere. Because it's same, I can calculate the answer. Otherwise, we can't find the answer for this one. Okay, we can simply put a equal to 1 and b equal to 2 and c equal to 4 and find the answer. Okay, moving ahead. What if we get a reverse question? We have been solving questions where we are given a over b and asked for the expression, some expression. Now this is a reverse question. You are given the value of the expression and asked for a is to b. To solve this kind of problem, simply cross multiply 2a plus b over a plus 3b equal to 3 over 5. Simply cross multiply. Multiply 5 with 2a plus b will give you 10a plus 5b. Multiply 3 with a plus 3b will give you 3a plus 9b. Now bringing all the a variables, a expressions on one side and b expression on the other side. This becomes 7a equal to 4b. So a over b will come out to be 4 over 7. This is the best way to solve this kind of problem. Simply cross multiply and it won't take time. They can give you any expression with whatever. And if they ask you in the reverse way, they'll ask you for just two variables only. They won't give you another third variable, C. Okay. Moving to the next part, it's about continued proportion. You have so many variables involved, then what to do? Then A, B, C, D, E, and F are continued proportion. You have A over B equal to B over C equal to C over D, D over E, E over F equal to 2 over 3. Then they ask you for the values of some of the expression. For example, they ask you A plus B over B plus C's value. They ask you for A minus B over B minus C's value. Or they might ask you A plus all of them, A plus C plus D plus E divided by B plus C plus D plus E plus F. They ask you for the addition of any two of them. Suppose they ask you for C plus D over D plus E or anything, any two or all of them. They ask you for the combination of any two of them or all of them. All of them will come only in addition, but two of them can come in the subtraction as well. Then what happens? Please remember, we don't need to combine the ratio here. We don't need to do much here. Please remember, this part will also come out to be the same, 2 is to 3. This will also come out to be 2 is to 3. The same ratio, 2 is to 3 and 2 is to 3. If you wish to cross verify if this is right or not, then you can simply combine the ratio and check. It's easy. It's combining A and A is to B equal to B is to C equal to 2 is to 3 will not be that tough. That's enough for you to combine and cross check. But still, that's not required. Just remember that whenever you are given the expression A, B, C, D, E, and F or whatever number in continued proportion and you are given their ratio equal to something, whatever, it's supposed given as equal to K, then even then you will have the sum of any two, A plus B over B plus C, or you can say A plus E over B plus F, or the subtraction, suppose B minus D over C minus E, it will all be equal to K, the same ratio. Alright, this was all about the ratios today. I hope you understood, and I'll be covering the real-time questions, whatever has already come in the exam in another video. Till then, thank you.